Today we're going to write equations of parallel and perpendicular lines. We have talked about perpendicular slope and parallel slope. You may want to write yourself a little reminder over here on the side. Remember that parallel lines have the same slope. And perpendicular lines have opposite reciprocal slope. So a couple sections ago, we found slopes of lines and then determined whether they were parallel, perpendicular, or neither. Now we're going to use what we know about parallel and perpendicular slope along with point slope form to write equations of lines that are either perpendicular or parallel. All right, now, how many of you are an older sibling? How many of you have younger siblings? How many of you are a younger sibling? Okay, so pretty much everyone is going to relate to this in some way. When a younger sibling comes home from Halloween trick-or-treating, what does the older sibling do with the candy? Now, does the older sibling take all of the candy? Or just like the best of the candy? The best of the candy. I mean, does the older sibling really care about the pencils and erasers and stickers and that crummy chocolate that tastes like wax? You know, nobody wants that stuff. So that stuff we leave to the younger sibling. I know this because I was the younger sibling and I always had the good stuff stolen out of my trick-or-treating bag. So this line that they're giving us, the line has the equation y equals 3x plus 7. That is the container of Halloween candy. And the good stuff is the slope. So what's the slope in this line? 3. We don't care about anything else in that equation. The rest of that equation is pencils and erasers and stickers. You know, like the Halloween-shaped eraser that doesn't even actually erase anything worth a darn, so what's the point of it anyway? Yeah, we're going to give that to the younger sibling. Write an equation of the line that passes through the point 1, negative 6 and is perpendicular to the line that has a slope of 3. So our original slope is 3. What would be the perpendicular slope? Negative 1/3. Remember, opposite and reciprocal. So if the original is positive, the perpendicular slope needs to be negative. Take that 3, change it into a fraction by putting it over 1, flip it to get 1/3. So negative 1/3. Okay, so really, I don't care about the original slope anymore either. Now all I care about is that the slope we are going to use is negative 1/3. The point we are going to use is 1, negative 6. So let's plug this into point slope form. Y minus a negative 6 equals negative 1/3 times x minus 1. Okay, I'm sorry. There is a fraction in this problem. I'm sorry. Negative 1/3 times negative 1 would be positive 1/3. To finish this problem, we would subtract 6 on both sides to get y equals negative 1/3 x, and then whatever 1/3 minus 6 is. Negative 17. Ooh, halo. That's algebra B stuff. So 1/3 minus 6, if I could type this in correctly, will give us a crazy decimal. To change that decimal back to a fraction on this calculator, math button, enter, enter, negative 17/3. Try number 6 on your own. Pause the video, give it a try, then play the video. I told you to pause the video. Pause the video. Do it. The only thing that we really care about out of this equation is the -3, the slope. I don't want that +2 to confuse you. That 2 doesn't go in there in any way. And if the original slope is -3, then the perpendicular slope, if I can write, is +1/3. So y minus 2 equals 1/3 times the quantity x minus 3. This time when we distribute that fraction, it makes something a little bit nicer, because 1/3 times -3 is -1. Add 2 to both sides. Y equals 1/3 x plus 1. This time it's asking for a line that is parallel. Parallel means same slope. So same thing at the beginning. Pick out what the slope is, throw the rest of that equation away. But this time, because we want a line that is parallel, we want to use that same slope. So we are going to use a slope of 5 with the point 39. I put number 8 on here because it is kind of a real world sort of, I don't know who really looks at this stuff, but a sort of real world application of what we're doing. This is the type of question that you could see on an ACT test or an EOC test. Basically, this type of equation in the past, a lot of you would read through it and say, oh my gosh, that's too many words. I'm done. I'm not even going to try. We have to get over that. You can't just be scared of lines of text and give up. You have to dive in and try something. Keep in mind, if you leave a problem blank on a test, you get 0 points. If you try something, you're probably going to get at least 25 to 50% of the points for that problem. But if you leave it blank, you get nothing. So in 1984, Americans purchased an average of 113 meals or snacks per person at restaurants. By 1996, this number was 131. Write a linear model for the number of meals or snacks purchased per person annually. Our first task is to write a linear model. When it says for the number of meals or snacks, they're basically telling you what they want the model to equal. So if we have a model that's like y equals something times x plus something, they want the y to be the number of meals or snacks. They want to be able to say, in this year, how many meals or snacks were purchased per person. So we need to be able to plug in a year and get the number of meals or snacks. That means x is going to be the year. If you can figure that part out, then you know how to set up your ordered pairs. So if x is the years, my first ordered pair can be 1984, comma, 113. In 1984, there were 113 meals or snacks per person purchased. In 1996, that number was 131. If you have 2 points, can you write an equation for the line? What do we need to do first? Find slope. So 131 minus 113 over 1996 minus 1984. What is 18 over 12? Three over 2? 3 over 2. Is that 1.5? You know, for this type of problem, I think a decimal would be just fine. 1.5 is easy to type in the calculator, right? Yeah, let's use 1.5. Then we need to pick a point. So step 2 is use point-slope form to figure out your equation. I'm going to use the point that has these smaller numbers. So y minus 113 equals 1.5. I think I'm definitely going to need a calculator for this one. Okay, so I have this model, y equals 1.5x minus 2,863. Now that 2,863, if you're looking at that and thinking, that's really like, I don't like that. There is another way that we could have set up our points. We could have said that x is the number of years since 1984, in which case this point would have been 0, 113, and this point would have been 12, 131. And then our slope still would have been 1.5, but then when we plugged that in, it would be 1.5x plus 113. So it'd be a slightly nicer model. But then when you use the model, you would have to consider, if we want to know how many snacks were purchased in 2006, how many years after 1984 is 2006, and that's the x value you'd have to plug in. Because we did it this way with the actual years as our x value, when it asks how many snacks are purchased in 2006 per person, you can simply plug in 2006 into the model. So yes, that 2,863 is a little bit unwieldy, but it actually allows you to have a slightly more usable model. Does that make any sense whatsoever? Maybe. So if I plug 2006 in, I get 146 meals or snacks per person.